Hello. Today, me and my friends would like to talk about an assignment we were given called Where is My Water? Now, the members of the group are Wazif, Farisi, myself, Imran, and Isai. Now, without further ado, let's get right into the topic at hand. Now, first let's talk about the problem statement. Now, in our opinion, the situation faced by Mr. Zahari can easily be overcome by applying the concept of fluid pressure. The management of the apartment should make adjustments to the pipe rod, the pumping motor, and the design and position of the water tank. All these adjustments should, of course, take into account the concept of fluid pressure as it is a main factor for the functionality of all the aforementioned components.
Alright, before we get into the main point, we would like to explain first the concept of fluid pressure. The concept of fluid pressure is applied in many kinds of situations in our world, such as construction of a dam and use of the siphon. The water supply system in an apartment also uses the same concept in this case. We will apply this concept in these improvements that we're going to propose right after this to solve the water pressure problems that Encik Zahari is currently facing. First of all, we would like to make adjustments to the pipes. Now, there are four commonly used pipes in plumbing. The first one is polyvinyl chloride pipes, or PVC pipes for short. They are not subject to rust and corrosion. They are also rigid and used for highly pressurized water. The second one is copper pipes. They come in two types which are rigid and flexible. They can last at least 50 years. The third one is chlorinated polyvinyl chloride pipes, or CPVC pipes for short. Now, they are very similar to PVC pipes but chlorinated. What this means is, when they are chlorinated, they can withstand extreme temperatures, up to 90 degrees Celsius. Last one is cross-linked polyethylene pipes, or PES pipes for short. They are rust and corrosion resistant just like PVC pipes. They are also very flexible just like copper pipes, and they are able to withstand extreme temperatures just like CPVC pipes. Now, taking all those pipes into consideration, we decided to use PES pipes and PVC pipes due to their benefits. There are also some more adjustments we would like to add to the pipes. The first one is bigger pipes between the floors. This is to allow the water tanks to supply a lot of water smoothly into the pipes. Next one is smaller but thicker pipes between each unit of houses. The smaller opening of the pipe allows the water to flow at a faster rate because of high pressure. When there is a high pressure, the wall of the pipes need to be thick to withstand it so that the pipe will not leak or break. Here are some pictures to show you how do PES pipes and PVC pipes look like.
Alright, next we have pump and motor. A pump is a device that moves fluids using mechanical action. This action is usually fueled by electrical energy that's been converted to hydraulic energy. There are mainly two types of pumps: centrifugal pumps and positive displacement pumps. Centrifugal pumps offer a higher flow rate and are easier to produce, while positive displacement pumps offer a more stable flow rate but are much more costly. This is mainly due to positive displacement pump being much more complex than centrifugal pump. Centrifugal pump has been chosen for this project because it is cheaper and the maintenance cost isn't very high. The pumps are placed at two locations, at the water tanks and on every floor of the apartment. At the water tanks, the motors that are inside of the pumps should be stronger because it takes a lot of force to transport water to every floor of the apartment. On the other hand, the motors that are inside of pumps that are on every floor of the apartment should be a little bit weaker because its main purpose is to equalize water pressure across floors so that Mr. Zahari's problem can be resolved. Here you can see the pictures of centrifugal pump and positive displacement pump.
Next, we will be taking a look at the design and position of the water tanks. The water tanks we have chosen to use are plastic water tanks. This, however, does not come without reason. Plastic tanks are more corrosion resistant and cheaper than metal tanks and the more old-fashioned wooden water tanks. The material our tanks are using is polyethylene, or PE for short. Polyethylene is a light, chemical-resistant thermoplastic. it is the most commonly used plastic for water tanks due to its strength and structural variability, since it can be offered as high density polyethylene, HDPE for short, known for its high strength to density ratio, and low density polyethylene, LDPE, for a softer variant of the material. However, it is recommended that we use the high density variant, as HDPE has little branching, giving it stronger intermolecular forces and tensile strength than LDPE. The tanks we are using will be cylindrical in shape, although change in shape will not cause a significant difference or unsatisfactory results. Here are some pictures of polyethylene tanks. As for the positioning of the water tanks, they will be placed on the rooftop. This is to ensure a minimal consumption of land or space, as planning a major expansion or renovation could prove to be costly. Multiple water containers are placed on the roof of a tall building. The structure supplies water pressure to floors at higher elevation than public water towers easily, as opposed to depending on ground level tanks. It is not that ground level water tanks do not have the capability to send water to higher floors. However, it would struggle and would need more pumps, which would also lead to further expensive. Here are some images of elevated and rooftop tanks. Now we will move on to our diagram of the water system we had in mind. First off, we have the standard water receiving tank. This tank receives water from the main water pump. It then pumps water to the polyethylene tanks that are on the roof. The rooftop tanks then collects water and stores it for later use and timely access.
Now for the pipes, as we have explained earlier, we will use bigger pipes between the floors and smaller pipes between each unit of houses. For that reason, we will use PVC pipes between the floors from the ground floor to the roof, as you can see here, because they are bigger compared to PEX pipes. On the other hand, we will use PEX pipes between each unit of houses, as you can see here, because they are small in size compared to PVC pipes.
I will explain again the position of the water pumps. There are two pumps placed outside of the building, one near the receiving tank and one at the water tanks. The pump that's placed at the receiving tank will pump water to the water tanks that are placed at the roof of the building, while the pump that's placed at the water tanks will pump water to every floor of the building. The pumps that are placed inside of the building, however, will pump water to every unit of the house inside of the building.
Now finally, let's talk about the conclusion. Now in conclusion, the improvements proposed are sure to be able to solve the situation faced by Mr. Zahari. These improvements will make sure that the house units of the apartment will all get equal water pressure. This will ensure that the house units with slower water flow will get improved water flow, whilst the house units with already fast water flow will maintain its speed.